We're back. We always back. We always back. Like I don't know how to start every lesson besides me saying we're back. So yeah, man. Might as well live with that. Right. Lesson 10, we're gonna be looking at test courses. What are we talking about when we're looking at test courses? We are saying that I think we're gonna need to move away from this whole P plant, heightened P plant, whatever. But anyway, let's use what we know. Heightened P plant. What do we know? For a plant to be tall, for a plant to be tall, we know that tall is the dominant characteristic. And we know that tall is dominant over what? Over short. Now, for a plant to have the phenotype tall, it means that the genotype for that plant can either be homozygous dominant or heterozygous. Whereas when a plant is short, because it is short, it is exhibiting the recessive trait. If it is exhibiting the recessive trait, then definitely that means that it can only be showing this phenotype if it is in the homozygous recessive form. Now, listen to this. P plant A is tall. What is the genotype? You don't know. That's the question. P plant A is tall. Write down the genotype. You can't. Why? Because tall is the dominant trait. And because tall is the dominant trait, you're going to have two genotypes that can give you that trait. You can either have homozygous dominant or heterozygous. So if you're asked that P plant A is tall, write down the genotype. You cannot conclusively write a genotype except to put down two options. Now listen to this. P plant B is short. Write down the genotype. That is clear. Short is the recessive trait. If short is the recessive trait, and we know that is being exhibited in the phenotype, then it stands true that for it to be shown in the phenotype according to complete dominance rules, it means that it must be in the homozygous recessive. Thus, it is able to appear as short. Because if one of these was paired up with one of these dominant ones, then this one, any one of these will be masked because it's the recessive value. I hope you get that. So in a test cross, what we're basically doing is that we are taking something that has a non-phenotype, but we don't know the genotype. And we're crossing it with something that has a non-phenotype and genotype. And then we observe the offspring that are produced. And then they will tell us if the unknown genotype is either homozygous, dominant, or heterozygous. Bear in mind that you cannot know the genotype if the plant is exhibiting the dominant trait. Hope you got that. Right, so what does this mean? Let's go. There we go. An organism expressing the dominant characteristic in its phenotype may be homozygous or heterozygous. You're getting that? I hope you're getting that. So this means that a tall P plant expressing the dominant characteristic tall in its phenotype may have two possible genotypes. May have two possible genotypes, either homozygous dominant or heterozygous. Right. However, the genotype of an organism showing the dominant trait. What is the dominant trait? of height, it's tall. So the genotype of an organism showing a dominant trait cannot simply be determined by looking at the phenotype. You can't do that. You can't. Right. If the genotypes of the parents are known, the only other way to determine the genotype is by means of a test cross. Right. So in the test cross, an organism that shows the dominant characteristic, which means that is the known what? Genotype, is going to be crossed with an organism that expresses the recessive characteristic. The moment it shows the recessive characteristic in its phenotype, then we definitely know that it is what? It is double recessive. And when these are crossed, the offspring will tell us whether the unknown genotype is homozygous dominant or homozygous dominant or heterozygous. Right. So let's say that we have an unknown tall pea plant. We have a tall pea plant. Genotype unknown. What are we going to do? For us to figure out the genotype of the unknown tall pea plant, we are going to cross that unknown tall pea plant with a short pea plant. Why a short pea plant? Because a short pea plant is exhibiting in its phenotype what? The recessive characteristic. Why is it able to exhibit the recessive characteristic even though it is the recessive trait? Because it is found in its genotype to be homozygous recessive. So we know that if we take a short pea plant, we already know what? The genotype. Homozygous recessive. Right. Give me permission, and I'll just do it here. Right in front of you. Right here, in this document. Right. So we have a tall pea plant unknown. So we're going to take two options here. We got tall here, and it's crossed with the what? With a short. Forgive me, I'm not going to do the key and what, I don't know the time, but you as a student are required to do it. Right. This tall pea plant, and you're going to write your labels, please. Make sure you always write your labels. They have marks. Your tall pea plant can either be what? This genotype or this genotype. So if we take the first one, homozygous dominant, so it means that it's going to be like this. Crossed by what? A short pea plant, or dengal, it's like that. Right. That is one possible cross. The other possible cross is that the tall pea plant is crossed with the short again, but the tall pea plant, another possibility of its genotype is what? Heterozygous. So here, instead of having homozygous dominant, it will be like that, and then here, it will be like that. I hope you get it. Right. Let's do the two crosses, the two possible crosses, and see what the results of the F1 offspring are. Right. Tall. Next thing is what? Meiosis. What do we get? We get that. And then we get this gamete. We get this gamete. And then we get this gamete. Of course, you can simplify it and then just, they give you the same. You see? So you can use one of this and one of that, if they give you the same. If you find what I just said to be complicated for you, just do it the way I'm doing it right now. Are we together? Right. This one here can cross with that one. And then you get this. This one here can also cross with that one. I think you agree with me there. This one can cross with that one. And then this one can cross with that one. Is that correct? Yes, it is. What is the resulting phenotype? F1 phenotype. All the offspring are what? All are what? At home. Right. Walk with me. What if the possibility was this one? this is what? Meiosis. This one goes into its own gamete. This allele goes into another gamete. This allele goes into one gamete. This allele goes into another gamete. Right, let's do the cross. This one can cross with this one. This one can also cross with that one. This one can cross with this one. And this one can cross with that one. What is the F1 phenotype for this one here? You have 2 tall and 2 short. Now listen to this. What did we start with? We started with a tall pea plant genotype unknown. By crossing the tall pea plant with a short pea plant genotype known. By looking at the offspring, then we can know the genotype of the unknown parent. For example, look at these two crosses. These are the crosses that we did. Right. In this tall unknown pea plant, if the pea plant was what? Homozygous dominant, and we crossed it with the short pea plant, what did we all get? All offspring are what? Are tall. If all the offspring are tall, it must mean that the unknown tall pea plant genotype must be homozygous. Because how can they all be tall? They don't even have one short one. It means that the unknown parent with the dominant phenotype must be carrying the dominant alleles. And what are they doing? They are masking the recessive alleles of the homozygous short pea plant. But if after doing a test cross of the unknown tall pea plant and crossing it with a short pea plant, and then your offspring come, and then you have a mixture. You have tall and short. It must mean that the unknown tall pea plant with an unknown what? Genotype. The parent. This parent must be in a heterozygous state. Why? Because for you to produce short pea plants, it means that both parents must have contributed a recessive allele to the genotype of the offspring. I hope you get what I mean. I hope you understand. I hope you understand where I'm going with this. Now walk with me. Look at this. Look at this. Just to finish up this thing, so that we move on from there. What conclusions can we bring out from this? These are the conclusions that we can have. If the offspring express the dominant characteristic, in this case here when we are using height in pea plants, and the dominant characteristic is what? Is tall. If all the offspring are expressing the dominant characteristic, it means that the unknown parent must be homozygous dominant. And if there are any recessive offspring, any recessive what? Offspring. And then in this case here, it will be the short pea plant. So in other words, having offspring that are short in height. Then it can only mean that the unknown parent is heterozygous. Why? Because for this cross to produce offspring that are short with genotype homozygous recessive, it means that both Parents must have contributed each a recessive allele in brackets T to the offspring's genome. And that, ladies and gentlemen, is a question that will come in exams, and what I wrote is what will be needed as the answer. I suggest that you take a screenshot. Take a screenshot, you write down these notes. I hope you loved the lesson. I hope you enjoyed yourself. Right, so this is us. We're done with the test course. Take care and enjoy yourselves.